Well, thank you very much for joining us and for agreeing to the oral history. I thought if we could spend a little time about starting at the beginning of your life story, if you will, and talk about your early childhood, your family. I know that you were born in Bavaria, I think it is, in '43, which is an interesting and tough time for Bavaria, I'm sure. And then I believe were you in Germany until the early 50s, is that correct?
Yes.
Just if you could talk about any memories you have of that time, your experiences there, your family.
I was born in a farming town a little ways outside of Munich.
Okay.
And actually we wound up, during the war, we wound up living in Augsburg for a while. And I do remember the Allies bombed the crap out of Augsburg one night. I finally found Augsburg was bombed one time, and the British sent 750 bombers over on one night. And we happened to be in town, which wasn't too pleasant, but I was young. I mean, so to hardly remember anything other than just thrashes. And then we went out on the farm basically to get out of town. But then my mother, we wound up back in Augsburg, and I remember playing and growing up in the ruins. The town was leveled practically. I mean, these pictures you see of towns in rubble, that was hometown. And so then, but then my mother basically married a GI in about 1950. And so my stepfather, he adopted me, and we came to the U.S. in 1952. And he stayed in the Army. And so we moved around the U.S. for a while, Virginia, Texas, and then actually went back to Germany, to Heidelberg for a tour duty. And I went to Heidelberg High School for, American High School at Heidelberg through junior year. And then he got transferred to Fort Ord, and that's the first time we got into California. And so I finished high school in Monterey, and from there I started applying to colleges and wound up, deciding to stay in California, and I picked Caltech, just got a scholarship, and it seemed like a good idea at the time.
Did you speak, when you came in '52, were you a native German speaker? Had you had any exposure to English?
Not very much. My stepfather didn't speak English at all. My mother obviously spoke English and German. And, your parents try to get you to learn English while you're still in Germany. Forget it. And got off the boat, and they put me in a elementary school in Virginia where nobody spoke German. And I said, this is not good. So I had to learn English in about 2 weeks.
Oh my God.
Just to survive in school. And we never spoke German again, actually, because my dad didn't speak German and my mom didn't, so it just went straight to English as best as I could. And unfortunately, what that did to me is I never got a real good understanding of the English grammar, how that goes. If you weren't taught formally a language, then, and I struggled quite a bit with getting decent grades in English in general, because, the King's English wasn't something I learned in elementary school in Virginia.
Right.
So anyway, but it was fun. We got through it.
Yeah. Did you have, when you were, in your education through high school, how did your interests in the technical side of things develop? Were there any experiences that really stand out for you, or was that through school or through hobbies, or how'd that emerge?
Well, school and hobbies, I think. Interestingly enough, the American high school in Heidelberg had good teachers, really good teachers. And so math, basic science and stuff, the teachers, I really enjoyed it. The teachers were good. And, and when I got to Monterey High School, they had an extra class that started at 7 in the morning, basically an electronics class, a lab, where you could build, solder stuff together, and I just loved it. I said, this is great, engineering, science, and so forth. So I guess I've always kind of drifted more toward technical, and part of the reason I couldn't pass a music course if I tried. I get tone deaf, and so I knew music wasn't going to be for me. So I went ahead and drifted toward science, and of course did my own projects, and for a while, built some rockets to see if, just like Gordon, build rockets and things you can blow up.
Did you have a chemistry set?
Yeah.
Yeah. I mean, did that get you into explosives?
Yeah. I had one of my rockets blow up in the bedroom, and my mother was a little mad.
I can imagine. Did you get into radio hobbyist sort of activities? Amateur ham radio, that sort of thing?
Yeah, but not so much. I mean, I think I had one for a while, but I don't know. I didn't feel like talking to people across the world.
Yeah.
So I never got into that. But I obviously, built the Heath kits and played with that sort of stuff. Yeah.
And growing up in the 50s, I guess, did Sputnik go up while you were in high school?
I think so. Yeah, I think so. It was like.
Is that right?
Oh no, well.
No, 56. I can't.
56,
remember.
I think. Sounds right. Yeah. Well, I would have been freshman. I graduated from high school in '61, so so it was right around that transition.
Era. Did that, was that whole world make an impression on you?
Nothing. I mean, other than wow, this is great. I mean, it didn't change the direction or anything. I kind of always wanted to do science. So.
Okay.
But.
And it sounds like that early morning electronics lab must have been, the passion project of one of the teachers, presumably coming in early and facilitating it.
I think so. Monterey High School was really a great school, and so they tried to put in extra courses. I mean, you had to take 6 classes a day or something, whatever the number was, and they would put in a 7th one and have different topics, obviously, but I picked the one that I was most interested in. And, you have to be passionate to go to school at 7 in the morning at high school. It's not the sort of thing you willingly do.
Well, you must have been good at it and done well in school, because it seems like you had some, good choices to make at the end of it. Can you talk about, where you, just that end of high school experience, figuring out what you wanted to do next, your kind of picture of where you wanted to go at that age?
Well, I mean, I obviously wanted to go to college, and so I applied to the usual schools, Berkeley, Caltech, MIT, and so forth. And, and I knew my parents couldn't really afford the tuition, and so I was fortunate that I managed to get a scholarship from Caltech. And I also got a separate scholarship, I think it was B of A or some, there were some small scholarships, and so so the cost to my parents was minimal. But even then, I wound up borrowing some money, to pay tuition. But I liked it. And actually, I think probably the reason I went to Caltech is because they actually send faculty members out to talk to the students before they accept them. It isn't just a paperwork scheme. I mean, you have to have good SATs, you have to have good grades, and so forth. But they specifically wanted to talk to somebody. Which actually probably helped me, because I did lousy on my English SATs. Never did get a hold of English properly.
So how did that, you would apply, and then if they were interested, they would come talk to you?
They would send somebody up to talk to you.
Do you remember who came to
I don't remember the name, but it was a faculty member, and I just wanted to interview. And I think they wanted to make sure they got fairly rounded people. And so it obviously worked out fine, but I was impressed with that.
Yeah, I would be too, I
Yeah.
think. Interesting. And the scholarship, they let you know when they accepted you
Yeah.
that they were all, oh, wow,
Yeah.
that's great. Had you been to Pasadena and Los Angeles and seen the campus before you arrived?
I think so. I'm trying to remember. It's a long time ago. I'm trying to remember. I'm pretty sure we toured the campus. I don't remember if I went back to MIT or not to look at the campus. Maybe. I don't remember.
Well, maybe we could move to a description of, Caltech and the Los Angeles basin and Pasadena as you found it when you arrived in 61. What were your impressions?
Terrible smog.
Smog.
Smog was unbelievable. I had done some track at high school, and got to Pasadena. I ran around the track and almost couldn't breathe. My lungs started hurting so badly.
Really?
I said, "That's it." I can't. It just didn't work. I mean, it was unbelievable how bad. From Pasadena, you couldn't see the San Gabriel Mountains, which are only about 3 or 4 miles away, and so it was just smog city. So I said, "Okay, this was a good idea." But you pretty much get busy with studies right away, and so you just, okay, live with it. And actually, I joined ROTC because my dad had been in the Army, and I kind of felt, okay, that's a noble career and a noble thing to do. And so I was actually in ROTC, and I dropped out of it actually senior year because they changed the rules. They had originally said that, okay, if you go through ROTC and then you want to go to grad school, first they said they would pay for grad school, which was a big deal. And then they changed it, well, we'll give you a 3-year deferment so you can go on your own. And then they changed that and said, no, we're not going to give you a deferment at all. You might get a 6-month deferment or something, but then you're going to be in the draft. Well, okay, guys, you can't change the rules that much on me, and so I dropped out of it. Screw it. And you'd probably still have the 4-year obligation after that. And so then they countered and said, well, we'll send you to Wright-Patterson Missile Guidance School for 1.5 years to get a master's. I said, okay, well, that sounds interesting. But for that 1.5 years, you owe us 3 more years, plus the 4 years you signed up for. I said, you got to be kidding. I've been
Now you're
in there
in for
for 7, 8 years for a master's. Forget it. And meanwhile, I had applied to Stanford and Caltech for grad school, and once again, Caltech came through and gave me a scholarship and a teaching assistantship and a 1-year master's program. So I said, here I am, And at that time, they were still giving college deferments, so I could at least apply for that every year. And then once I got the master's, I had run into Carver Mead as an advisor, and I just thought he walked on water, great. And so I said, I'd love to stay for a PhD here, and so he helped me and stayed for the PhD.
Were they changing the terms of the ROTC commitment as kind of the American involvement in Vietnam
Yeah,
was
I'm sure that was
deepening?
that was part of it. Yeah.
Yeah.
I'm sure that was part of it. But I suspect they haven't changed them since then. I don't know. So it was probably too good a deal, and so.
Right.
But yeah, I'm sure Vietnam was just ramping up. It hadn't really started, but it was ramping up. So I suspect that they were anticipating some issues.
Right. There's a lot of different ways to go. Sorry.
No problem.
Just maybe you could describe as an undergraduate, were you, double E when you walked in the door, or did you discover that?
No, actually, at Caltech, the first 2 years, it's everybody the same.
Oh, that's right.
Physics, math.
That's right.
And I remember actually being relatively unhappy at times. And the reason is I knew I wanted to be an engineer. But you had to take the math and physics basic courses with all the guys that really wanted to be mathematicians and physicists. And I'd say, I don't care, guys, it's okay. don't try to flunk me out. I don't want to be a mathematician or a physicist. I just want to get a double E. And so the first 2 years were pretty miserable because you're competing with these guys that really want to be physics, really chemistry, those are the hard courses. And we had Feynman for physics, we had Gell-Mann for math, and Pauling for chemistry, okay? And so, and they had the best TAs that were just mean as skunks. And so finally, junior years, when you could start to select, and I said, hey, engineering, double E, and then the courses were great. I loved it. My grades went up. I was able to finally work on something that I wanted to do with guys that were interested in being engineers and not try to compete with the mathematicians.
Those are three very impressive teachers to have as an undergraduate.
We were incredibly lucky. I mean, our class was we went through the Feynman lectures, which are the big deal, when he was first doing them. And he's great, So anyway, but he really made it interesting.
I've heard from other people that Pauling's approach to general chemistry was to come in and talk about whatever he had been thinking about on that particular day.
Yeah.
Was that your experience?
The problem about Feynman was really kind of the same way. Feynman wanted to do this great lectures, but the problem was the book they gave us was Halliday-Resnick, and all the tests were out of that book, and the TAs, everything was based on that. So you'd walk out of a Feynman lecture just, I got this. Then all of a sudden you see a test that had nothing to do with what Feynman talked about. I said, why am I wasting my time listening to Feynman? I got to go get that Halliday-Resnick book out and study. So, I mean, it had its ups and downs. And Pauling was the same way. Grand lectures, wonderful to listen to. But then when it came time to the tests and everything else, it was out of a different book or out of the book, and the TAs were making up the tests. So it was an interesting experience, shall we say.
Well, once you got out of the maw of that and got into double E, what was electrical engineering like at Caltech then? Was there, and the relationship to computer science and exposure to computers?
They really hadn't started computer science in those days. I mean, it was
simple enough.
In those days, math, physics, chemistry, double E, whatever. What I found so fascinating was that the equations that govern electricity are really no different than govern mechanics. If you think about a spring oscillator versus an electrical oscillator, and so the underlying mathematics for all those things are actually very similar. And so then you started to say, well, this is kind of interesting, how it all relates. And so that was sort of the big aha. And then you could get into that, and you actually developed a better understanding because, okay, electricity flowing through this isn't some mythical thing. It's no different than a spring or a pendulum or water flowing, So it was kind of fascinating, but I found the last 2 years, junior, senior year at Caltech, great because I was finally what I wanted to do, and so anyway.
Was there a lot of hands-on lab component in those 2 years?
No, not so much. Senior year, we had some labs, and I think that's where I met Carver Mead.
Yeah.
Because he was teaching a course, and it was kind of solid state electronics at the time. The transistors were really just kind of getting going and things like that, and so I thought that was really interesting, and I worked on some stuff for him, and I think we were trying to modulate light using some sort of crystal, shine a laser through it and modulate the light, and prove that you could modulate the light, whatever. But I was lucky enough to get a summer job with one of the professors in mechanical engineering between junior and senior year, I think. And he had me taking data on he was doing earthquake studies,
Oh.
where you could you shake a building and you measure the resonance of things and so forth. And so that was really interesting. And I was basically a lab technician doing the lab work. So I got into, I liked the lab and I liked the experimental stuff a lot.
Mm-hmm. Did you have any, in the summers, did you have any, work with local technology firms, or did you work in the summers, or how'd that work out for you?
I started working in the summer. I mean, after my, junior year, try to get it all straight. I actually worked at Edwards Air Force Base, and I think that was after the junior year, summer, worked for the U.S. Air Force, and I was calibrating altimeters for their test aircraft. And so actually that's where I learned how to program, because I finally wrote a Fortran program that would take the data and, analyze to see if the altimeters were working properly and reduce the data. I don't remember much about it, but it was,
they were digital altimeters, or they were recording somehow?
they're mostly recordings.
Yeah.
I forget how, you're stretching my
Sorry.
memory. But so I worked for them, and then I actually went to Texas and worked for Mobil Oil, and wound up repairing their analog recorders. They had these big TI racks, and we'd go out to West Texas, and they'd drop a thumper truck, smashing sagebrush, and record it, and all that stuff was TO5 diode, transistors, and the boards would go bad, and so they'd send them in, and I'd take the boards, figure out what's wrong with them, replace a couple transistors, ship them back out, and it was fun. So I did that, and then one summer I worked for Hewlett Packard, HP Associates, and that was building diodes, some space charge limited diodes. I worked for Varian one summer where we were making night vision stuff, where you'd get, basically you put cesium onto a gallium arsenide substrate so that you could have night vision. Huh. And then I worked at Fairchild one summer, and that was the first time I met Grove. And so then after that, I got out of school. I was graduating, and I actually came up to, and I met Gordon Moore a couple times then, and I actually came up to interview at Fairchild, and Intel had just started across the street, and Don Palmer was their HR guy. He interviewed me, and then he said, "Where are you going next?" I'm going over to Intel. He said, "Oh, okay. Come back when you're finished." And so I went back over after I had talked to Noyce and Moore, and he said, "Did they offer you a job?" And I said, "Yeah." And he said, "Take it."
Really?
Yeah.
That's so, and no compunction about that, or wow, huh? Maybe he was wishing for an offer himself.
Yeah.
Well, if we could go back a little bit to talk about just your work with Carver Mead, mm-hmm. and he must have been a pretty young professor at that point.
Carver's about 10 years, he's close to 10 years older than I am. So basically, I was starting to work for him when I was, 21, 22, and so he was 30, and he had just been a professor, just gotten to be a professor.
Right.
But Carver is just great. I mean, I can't say no positive about him. I mean, he makes things simple, doesn't flaunt how smart he is or hide behind any robes, quite frankly. I mean, he's very down to earth. But Carver got two types of grad students. One type with brilliant physicists like Tom McGill or Carl Thornburg. And then he got experimentalists, because Carver always wanted to have a lab and prove things worked. And so he knew I knew how to do lab work. I wasn't so good at the math or theory, but he said, so he had a couple of those grad students that were very much in the lab, keeping the lab running and doing the experiments. And he had the really great physics-minded guys, math-minded guys. So he had the best of both worlds going, and that's Carver, and he was good at both.
How big was his lab that you were in? You know, number of people.
He would have
Or-
typically about 6 or 7 grad students.
Okay.
And he'd try to get them out. I mean, Carver was get the thesis done and get out and move on, not one of these professors that wanted to have free labor for 5 years. And Carver was very much, let's get this experiment done, let's get you out of here. And he did.
He seems to also have been, just from speaking with other people, very involved in placing his students, you know, like helping them to find a position and maintaining that kind of network of his students.
Absolutely.
And, you know, far after, you know, far afield from the Caltech campus and way through time. Is that accurate?
Yeah.
Yeah.
Well, I was down at Caltech, and they asked, I had to make a short speech or something, and I said, Caltech is great. I got a degree. Carver Mead got me my degree. He introduced me to my wife, and he got me a job. Now that's full service. But yeah, Carver maintained a lot of relationships outside, and quite frankly, companies would call him for students. I mean, when I was at Intel later, trying to recruit people, Carver, who you got that's good at this or that? And so he had quite a reputation for producing good students, and so we sought him out. But he didn't just, he got you out, but he didn't get you out and dump you. I mean,
Right.
He got you out and into something. So it was great.
Yeah, and it seems then that he had, you know, connections into all these different organizations too. And I guess by this time he was also consulting pretty widely. I think he was consulting for certainly Intel when you finished. And Fairchild before.
He didn't consult that much for Intel.
Oh.
And I mean, he talked to Gordon a lot.
Yeah.
But after a while, Intel wasn't Carver's favorite place, in the sense that Carver is full of great ideas. Let's go do this and go do that. And Intel got much more hard-nosed under Grove, which is get this stuff to production. I want, performance reports. I want things done.
Right.
And don't waste your time on other stuff. That's one reason that Andy and Bob Noyce kind of tangled occasionally, because Bob had lots of great ideas and lots of things to do, and Andy just wanted, let's get this done. And so Carver still would consult with Gordon, and I would talk to him once in a while, but he was never a big-time consultant for Intel per se, because he viewed Intel as being a little bit too much nose to the grindstone and don't look this way or that way.
I get it.
That's fine. I mean, that's Carver.
Yeah.
But he was involved in a lot of consulting, and I know he consulted for Hughes Aircraft. He consulted for Intel. He always had a lot of DARPA support, and so that got him a lot of exposure. And so, no.
Well, if I reflect on some of the names that you just mentioned of places where you worked in the summer, you kind of went to some of the most storied places, of tech companies in Silicon Valley to get that exposure before making your choice of what you wanted to do. I just wondered if there were anything, did you take anything really in particular with you from that exposure to HP and to Varian and maybe to Fairchild R&D? Anything stand out from those places?
Well, I mean, the usual cliches. I mean, HP was a great company to work for. They, but they were a little easygoing, shall we say. I would show up to work at 8 o'clock in the morning, ready to go, and the technicians would show up around 8:30 or 9, and the rest of the staff would show up when they felt like it. Okay, it's a little laissez-faire, but they did good work. I mean, they had great labs. I worked at HP Associates, and great people. So, but a very employee-oriented company, but not very confrontive. It was very much family-friendly stuff, and so if somebody wasn't doing a good job, they really didn't know how to deal with it.
Right.
So there's a kind of lesson there, you know. At Fairchild was kind of interesting in the sense that it was very clear there was R&D and there was manufacturing over there, and the R&D guys, it wasn't clear, you know, what they were up to half the time, but it was really interesting. But again, you had the likes of Videz, Gordon Moore, and you know, some really, Ed Snow, really good people, and so it was hard not to like working there. But they were also kind of lazy, shall we say. I remember one time I rode my motorcycle up to Northern California, whatever, a damn thing broke down, I got stuck. And I wasn't any way I could get to work on Monday morning at 8 o'clock. I left a message for my boss, Des, I'm gonna be late, I'm really, really, really sorry. And the message was there. I got to work at 10 o'clock and he still hadn't showed up. I said, okay, I get it. No, this is how it's gonna be.
And at that time, it must have been that big new laboratory building that Fairchild built, right? It's down.
No, well, it was the one by the
Miranda?
Veterans Hospital,
Yes, yeah.
which was a separate R&D
Oh, I
lab.
guess they built that in '62
That was
or something.
Arrestadero and Foothill.
Right.
Yeah, no,
right.
that's where I worked. And Varian was just off Page Mill.
Right.
And the Varian thing was much more, I worked in one lab, really with just one guy, and didn't get much exposure to Varian, but it got really good exposure to high vacuum systems and, you know, running experiments. And so that was, again, a great learning experience. So I learned a lot in the summers. And I was determined to get out every year from school during the graduate years, get out and get some experience and pay for school.
Yeah.
Minor details, but that's okay. And then at Caltech, I was actually a lab TA for quite a while too. And you know, took care of a couple of the labs for the professors and basically a TA. You know.
I was refreshing myself this morning about the work that you did for your PhD thesis, and you know, tunneling in Schottky barriers on top of 3.5s, right?
Right.
And I couldn't help me if you could. I mean, Carver was making some very, very fast devices around this time, wasn't he? Out of 3.5 materials, was there a connection there, or?
No, Carver at that time was very much into current flow, tunneling characteristics of thin films, tunneling characteristics, and actually just diodes per se. Okay. You know, so we were trying to make diodes on zinc sulfide, and you know, and just basically anything to do with electron motion in solids, semiconductors, and so we would try different compounds, and gallium arsenide was an obvious one because it was easy to get. But like I say, I was growing crystals, zinc sulfide, to try to see if we could get, because theoretically you should be able to get a space charge current through them. In other words, it had the right band gap, just didn't have any electrons. So if you could get electrons into it, you could presumably get a space charge current flow. And so we were working on that sort of stuff, you know, and we're always fighting surface states because, you know, the minute you break something, you've got a surface state which interferes with the electron flow.
Very good preparation for silicon devices, I would think.
Yeah,
Battling surface states.
That was the game. And tunneling. EPROMs are tunneling, right?
And I guess the craze for tunnel diodes had kind of coming. I mean, that was the late 50s, wasn't it? That first craze for tunneling?
Yeah, I don't think they ever
devices?
really had much commercial value.
Yeah.
The tunnel diode was actually much more of a physical phenomenon, which was really interesting to study. And it led to a lot of understanding about tunneling in general. And, you know, nowadays, with technology getting so, we're down to monolayers of silicon and, you know, basically the whatever we are, 10 nanometer technology, whatever, and then those are all getting to be dominated by effects like tunneling or avalanching. And so we worked on that stuff 40 years ago, but it was still rudimentary at that time, but it was really the basic understanding of that physics that was important.
That makes sense too, because by this time, Carver and his co-author, they did, I think, those 2 papers on, that I think were looking at how small you could make silicon devices.
Oh, yeah.
Weren't there 2 papers? So looking at these kind of limit phenomena for the scale, makes sense.
Yeah, no, Carver was, that wasn't the real goal at the time. It was much more just, this was in the infancy where you're just really learning about
Right.
semiconductors and tunneling and so forth and so on. So, so Carver was just exploring. And then once he got kind of tired of that, by the time I left, then he started in on computers, layouts and
Right.
and so forth, and got much more involved in the computer science. And so Carver didn't beat anything to death. I mean, he learned what he wanted to learn, get some stuff done, and then move on to something else that was interesting to him.
Was you were bringing that dissertation thesis work, to a close and thinking about your next steps, it sounds like you were concentrating on going into the semiconductor industry.
Yeah, by that
Okay.
time. Oh, yeah. Yeah, even though it was still double E, but that's the only choice you had. They didn't have applied physics or all the other fancy,
Right.
subspecies. Now it's double E, and
Yeah.
but no, Carver was very much semiconductor, and so that path was pretty clear. And the only thing is, well, at the time, I didn't really get into design. In other words, Carver later started, like the layout, the design work. But back when I was a grad student, it was still very much the physics of semiconductors. And so, but later, some of his students became designers, actually worked more in layout and design. So Carver kind of transitioned. But at the time, circuit design wasn't what Carver was interested in. There were Floyd Humphrey was circuit design type stuff at Caltech, but I wasn't working for him.
Right.
So I kind of stuck with Carver, and it was fun. I mean, I enjoyed what I was doing. So.
I would think that you would have had a whole passel of job offers to choose from. Can you talk about that?
Well, the usual suspects. I mean, TI, Hewlett Packard, Fairchild. Trying to think of who else. Hughes Research. Hughes Research kind of interested in me because I knew Carver was a advisor there, and they were doing some interesting stuff.
That's in Malibu.
Malibu.
Yeah.
And GI offered me a job, but I just couldn't bring myself to go to Texas after having worked there for one summer. Out in the oil fields. I said, I don't know about Texas. And so then Intel just popped up. If Intel hadn't started at that time, I'm not sure where it would have gone. Probably Fairchild, to be honest. I mean, I still respected Fairchild a lot.
Any interest in going to Bell Labs or any of the RCA operations at that point?
No. I don't recall getting very interested in those.
Right.
I think I might have talked to the recruiters when I was first graduating, but I don't know. I think once you live in California for 10 years, I don't know if I want to go back east, which is a terrible thing to say because back east is lovely, I'm sure.
Did you, so had you met some of the people at Fairchild who you knew were going to be over at Intel when you decided to join them?
No.
Okay.
Because I think by the time I actually accepted the job at Intel, Vadez had already joined, Grove had joined, Gordon and Bob, obviously.
Yeah.
And then they brought in Gene Flath, who was in manufacturing.
Yep.
I never knew him. So, no.
Okay.
I don't think so. I mean, actually, Ted Jenkins was at Fairchild. I knew him, and of course Ted came over, but he and I went to college together, so that doesn't count.
Well, maybe you could talk about the time you spent working I guess it must have been in Pasadena for Intel in this light emitting diode operation.
Just don't tell the EPA.
Oh, yeah, Scout's honor. Yeah, right. Probably some not contemporary practices in the lab at that time.
In those days, I mean, we didn't know what was bad, and people just did things. And now, my God, you get in trouble. But yeah, that was Carver and Jim McAulden's doing. They convinced Gordon Moore to start a light emitting business, and they actually brought Ted Jenkins down.
Right.
And so Ted and I were roommates while he was working there, and I was just finishing up a degree. And then they, about the time they needed to get Ted back up to work on bipolar, Gordon and Carver still wanted to keep that thing going, and so that was actually what I was hired for. And so I took over that, and the lab was a drafting office on the second floor of a rickety old building on Walnut Street. And Carver, he drove me nuts a little bit. He and McAulden in that lab were just, okay. We needed liquid nitrogen for the evaporator that we had. Have you ever tried to take a liquid nitrogen tank up a set of stairs?
I have never.
Carver and I would do that. I think I was pulling, and he'd had a crowbar to lift the thing up one step at a time. We get the thing up, and get it up. It took us like an hour every time we had to get that nitrogen tank up there. I said, you gotta be kidding. Then we needed 220 for the evaporator, and of course only 110 plugs. So Carver, knowing electricity, right, two-phase, we took an extension cord, cut it in half, plugged one into one outlet, and plugged the other into another outlet, and we had power for the evaporator. Then McAulden started running experiments. He damn near killed Carver because he had a tube furnace, and he was doing high pressure diffusion. And he welded an ampule together and opened the furnace, and then he heat the thing up. And Carver and I were sitting there working, and all of a sudden, kaboom! This projectile shoots across the room and hits the wall right next to us.
Because one end blew out?
Yeah, and so then I called Gordon. I said, Gordon, it's not safe working here. We got to do something. So Gordon ordered a blast hood, this big, heavy hood, and it must have weighed 1,000 pounds. And he had it delivered by Beacons, and 4 guys carried this thing up the stairs. And so then and the reason, actually, Gordon didn't believe me when I said McAulden almost killed us. So when Gordon and Bob were both there one time, McAulden was off in his little chemist suit, and this time he had an open pot furnace with zinc in it. And next thing you know, kaboom, zinc splattered on the ceiling all over the place. And that's when Gordon ordered the blast hood. So you got
to do all those operations to put the furnace inside of the blast hood or something, or?
Well, no, that's when we tried to grow our own silicon dioxide, where you had to use silane and
a bigger bomb.
We had a bigger bomb. Wow. So anyway, but no, one time I was trying to grow some silane and a homemade deal, and all of a sudden it caught fire, and it was just fire. It was in the blast hood of the fire, but I was trying to, something banging on the door, and it was a neighbor who was upset about something, noise, and he said, I said, I'm really busy. He said, what's going on here? I got to get back to what I'm doing. Look at that corner of my eye, there's fire going. There's a neighbor complaining. I said, I can't let him in. Call the cops.
Oh my gosh.
But anyway, we had a great time. And then about that time, the semiconductor stuff was starting to take off at Intel, and so Bob decided to sell the light emitting business to Monsanto.
He must have had some results if he could sell it to Monsanto.
Well, we were getting blue light emitters. I mean, it was nowhere near any kind of production type stuff, but we actually were able to control the color. And in those days, everything was red or infrared, so we actually could get different colors. And nowadays, of course, people use gallium nitride and other stuff. Yeah. So, and Monsanto was interested in getting something that had multicolored And so they thought, well, maybe they could get it to production. And we were to the point where we were going to have to spend some money. I
Right.
mean, you know, it's like, okay, we proved that it works and we can make a few of them, but how are you going to make millions? And so Bob Gordon decided to sell it, and they asked me, do you want to go with it? And I said, well, not really. I think I'd rather stay at Intel. And I said, okay, you're fine. And so I just decided to stay and then start working on, you know, semiconductor stuff.
One last question about the light-emitting diodes. Monsanto, at that time, unless I'm mistaken, was producing wafers, and I think even epitaxial wafers too. Was there a connection there? Were you?
No. I think
Okay.
Monsanto was just had, you know, a typical big corporation, had an interest in growing the business and
Right.
eventually maybe making wafers for those or making the product. So it was the local. It wasn't Monsanto seed company. I mean, seed guys. I mean, it was they had a local lab.
St. Louis.
I think it was in Cupertino. I think.
Oh.
I think that's where they had it, and so because I had to transfer all the equipment and transfer stuff to them and show them what we had done and
Right.
how to do it. And I think they played with it for about a year and then decided it wasn't worth putting a lot more money into it and gave up on it.
Well, when you chose to go with Intel, was that to, had they built the facility in Santa Clara yet, or were you went to
It's
the
Mountain View.
original?
Yeah, Mountain View.
Yeah. Could you talk about the job that you had when you arrived and who you were working with and what the scene was like in that building?
Well, they knew I had arrived because my motorcycle showed up on the loading dock, and Keith Thompson said, "What the hell's going on here?" I said, "You got my bike? Thank you." You know, I just shipped it straight to Intel. And so,
was it in a box or just in the back of a truck or
I
something?
don't know.
Yeah, who
The
knows?
moving company took it. That along with the blast hood. But anyway, no. So I basically wasn't sure what I was going to be doing because we had sold and so officially I was a member of technical staff, and so Gordon sat down with Gordon and said, "What do you need done?" You know, and Gordon says, "Well, we've got potentially major issues on reliability." At that time, the Schottky diodes on the bipolar were collapsing, and so he said, "Why don't you go look at that and work for Des Fitzgerald at the time?" And that was he was running QA, and so I was just tasked with problem solving, quite frankly. So probably for the first year, I was doing nothing but, okay, why is this not working? What's wrong with this, and so forth and so on. And so I think I went through most of the major early crises of things not working, single bit failures and loose wires and packages, one thing after the other. And so I wound up heading up reliability engineering because we had to get more people in to solve the problems. And then after Des Fitzgerald went over to Microma, they put me in charge of all of QA, which was fun for a while because it was very much day-to-day problem solving and here's what's going on. And of course, whenever Grove and I would get into what we can ship and what we can't ship, and we only got in trouble a couple of times by me listening to Andy.
Urgent, erring on the ship side. Yeah.
Well, we had one where the guys were bonding too far out on the lead frame, and so when you put the plastic around them, a couple times the bond wires are outside the plastic, which is not good.
No.
I said, "Andy, we can't ship this stuff. They're going to fall apart." And so we compromised. If we're just inside the plastic, it's okay to ship them. Well, of course, those came back too. And so, okay, Andy, we're not going to do this anymore. Going to stop talking to you.
Well, a couple different things. I would think that coming in to solve those, to address these reliability and quality problems is, yes, a high pressure situation, but also a good way to get into, all the details of the manufacturing process, the assembly process. You really have,
Yeah.
to figure out what's causing it, you really have to go deep into
Oh,
the
I actually
steps.
would go into the fab and etch the wafers myself.
Okay.
I go in and say, okay, part of the problem we're having with these things is they're not getting etched. And so I'd go in and a couple of lab techs took me under their wing, and we'd go in there and we'd etch them and see what it looked like. And so, but in general, we had really good guys working there. I mean, Tom Rowe, Ted Jenkins, Gene Flath, and so forth. And so it was very easy to work with them. And okay, here's the problem. Let's work on the problem, figure out what's wrong. And it was fun.
Because it would seem to me that the problems that somebody like Tom Rowe or Gene Flath would be working on to, get the manufacturing process to, produce working devices, to get yield are the same sort. It would be the same sort of approach and questions that you would come in from that reliability point of view. I mean, imagine it was a common language, if you will.
Oh,
Yeah.
I mean, the product had to work, and it wasn't supposed to fail. So, other than that.
Could you talk about, in that original Intel building, just how it worked kind of spatially, where were you and where were I don't really have a good sense of, how it was laid out. Was everybody all together?
It was a pretty small building.
Yeah.
I mean, it had, the fab was kind of on one quarter of it. And then across the front were offices and engineering offices. And then down the other side, we had the reliability and ovens for burn-in and so forth. And then right in the middle were actually the assembly line where they were assembling stuff. So in the early days, everything was just right there. And just, people kind of worked together. And so.
You were employee 99, is that what I saw? Something like that?
Oh, when was it? Oh, I was number 99. Yeah, I joined just below 100. Just got in under the wire.
One thing that I have come to learn is that neighborhood in Mountain View, I guess across the street from Fairchild Manufacturing, I guess Jean Arny had that building before and was doing fabrication with Union Carbide. But I think there was groundwater pollution from the manufacturing plants. Not just at Intel, but in the neighborhood and in the industry, how aware were people at that time of those environmental concerns?
At the time, it just, TCE is viewed as horrible, right? I mean, I'd take a beaker of it home and use it to clean my carburetor.
Okay.
Because it was a great cleaning agent, and you didn't think anything of it. Then all of a sudden, oops, you're not supposed to have that stuff. It's not supposed to be in the groundwater. And then, of course, and I think a lot of it was tanks that were leaking. I don't think people dumped it on the ground deliberately. It was just leaking tanks. And if you parked your car downwind of the Fairchild building, it would rust because there was so much hydrochloric acid going up in the smokestack.
Really?
Yeah. So, unfortunately, we don't do that anymore, obviously. But it was, but then we really had to clean up everything. But then you get into the flip side, which we have now, where the EPA has, quote, zero tolerance for certain things. I mean, so, okay, in those days you could measure 100 parts per million of TCE in the water.
Right.
And then they would ban that. Well, then the technology got better and you could measure 1 part per million. Oh, okay, let's outlaw that too. Well, at what point do you stop? There are certain thresholds where there's just stuff in the air.
Right.
And then it got into overkill situation.
Yeah.
Something that really needed to be cleaned up, got to a safe level, now becomes a zero tolerance. If you detect one atom, it's bad. So, but yeah, that building was a real problem for us in a sense, and so we wound up having to pump groundwater and carbon filter it and so forth, and try to clean it up so that it didn't create problems. But I think I'm pretty sure I'm right on this. The Navy down at Moffett was washing their planes in TCE.
Oh my God.
And they never got in trouble. It's probably all in the Bay. It's, the Army and terrible, Navy Army. But anyway, no, that was an unfortunate thing to be a Superfund site and have to really deal with stuff that you didn't know any better. So,
had you, just looking forward, just keep on the environmental topic for a minute, when Intel was starting to construct, its own fabs and, its own buildings in Santa Clara, in, Oregon, New Mexico, where have you, was that awareness about certain of these environmental harms or problems? Did you already have that when you started to build your own factories, or?
Oh yeah, I think so. Yeah, because by the time we were building our own factories, no, we just always tried to do the right thing. We put scrubbers in, and and neutralization, and I don't recall ever a situation where, well, we can dump this, it's okay. No, there was never any of that. And even when we were building in Europe, Europe didn't require scrubbers on your exhaust. You could just, and I asked the guys over there, actually Phillips guys, and I said, don't you guys realize this stuff going up? And they said, we don't care, the wind blows it all north to Denmark. I said, okay, I guess I understand how that works here.
Yikes.
And so no, we use the same standard for every fab and had the same safety protocols and stuff. So Intel had I think a really good record on that. I could never find anything. And I was big on safety. I mean, I reviewed the safety procedures at every factory, every visit.
Mm-hmm.
And so we'd have some lapses, but go get there one time and I said, why aren't those guys wearing hard hats? Oh, okay. Get some hard hats.
Well, to shift back to, maybe we could just talk a little bit about some of those, reliability issues and problems that you were tackling early on, if any really stand out as either unusual or representative, just
where should we start?
Yeah, I'm not sure. I'd love to hear just about some of those stories.
I can go a little bit of a laundry list for you. I mean, at one point we would stress test the junctions on the bipolar, and then we'd do a quick burn-in, and it had shifted. And it turned out the stress test itself was avalanching electrons into the oxide, which changed the characteristics. And I remember saying, what the hell's going on here? And I went to talk to Doug Froman, and Froman explained how avalanching puts stuff in the oxide for the EEPROMs. I said, oh, okay, there you go. Fix that one. All right, stop stressing them that way. Then we had single bit failures, which I should blame Videz on this one because but I think it was Videz. We had this clever idea of having the polysilicon go down directly to the substrate.
Mm-hmm. And
so you'd open up a substrate contact, deposit the polysilicon, and then you put oxide, and then you put metal. Well, it turns out, it took a while to figure out, right in that little area, sometimes the silicon would grow single crystal and shoot a spike straight up. And then later, when you put the metal on, it would zap.
Oh, it's short.
And I tried to get Videz to move the damn metal lines, and he refused to move the metal lines. And so one of my altercations, shall we say. So we worked really hard to not let the silicon grow, but it was tough because it wants to grow single crystal on single crystal. And finally, Videz had an electrical problem, which was it was coupling too much too much capacitive coupling to that silicon. So we moved the metal line to solve that, which solved my problem. Still hate him for that, but anyway. But that's the kind of stuff you run into, you know. And Gordon's invention of using phosphorus to flow the glass was great, except that it made it moisture sensitive. So then you'd pick up moisture, and we'd have water in the packages, or basically not water, but it would fail because of moisture.
Because it would affect the metal lines,
The
correct?
phosphorus in the glass affected the metal.
And it would basically etch away the metal or something?
Oh,
in
I
the
think,
package
I'm
or
trying to remember what
something?
the failure mode was, but basically, it was mostly in plastic, because it didn't work, ceramic packages wasn't a big deal because moisture couldn't get in, but plastic, it would get in, and then you get moisture in there, and with the phosphoric acid would etch the aluminum, and off you go. And so a good thing leads to bad things, you know, and so we went through a lot of really interesting kind of things. There was the soft error problem with, you know, cosmic rays, and actually I was trying to prove, we were trying to figure out what was cosmic rays, and so I bought something like 10,000 pounds of lead, and lead bricks, 50 cents a pound. And then we built a cave out of lead, and I bought very low alpha radiation lead, so it was super to stop the cosmic rays, and we put a system in there to see if it still failed. And then it turned out it did, because the radiation was coming from the sorted package.
Right, from the ceramic, right?
From the ceramic. And so then I had to get rid of the lead, so I sold it for $1 a pound, except Gordon wanted to keep about 100 pounds of it for sinkers.
Oh, did he really?
Yeah.
Did
So
he use it to make sinkers?
Yes, I gave him
That's
lead bricks.
hilarious. And you could get those with that particular radiation characteristic, because I imagine that sort of stuff.
Yeah, we had to go to a special mine in Utah or someplace that had low lead processing, and I tried to actually buy up the capacity, because I figured we might need it.
Oh, yeah, to put a film of it in the package or something?
Well, because the glass had lead in it.
Oh, mm-hmm.
That's the problem. The sorted package glass is lead and glass, and the lead was causing the problem.
Interesting. Oh my gosh. And I guess the EEPROM had been developed by the time you first arrived,
yeah.
or that
Well,
was
I mean, it was
in development.
in development. I mean, nothing was in manufacturing when I arrived. Okay, it was all we hadn't shipped the first product, but yeah, Frohman was doing that in the early 70s.
There's this perennial interest in how that trio of Moore, Noyce, and Grove, how they interacted and how they each helped to lead the firm. Just wondered if you could reflect on that from the earliest days when you were there, if you could characterize that and maybe think about also if it changed or not over time.
Well, I mean, now it's obviously totally different, right?
Well, yeah, sure.
No, I mean, there have been enough articles written about that, but I used to teach the Welcome to Intel kind of class, and I'd always start with exactly that discussion.
Oh.
Here's a picture of Andy, Gordon, and Bob together. And I said, I want you to remember this, because Bob was a visionary that the sky is the limit. Gordon was absolutely the brains in terms of technology and strategy, and Andy was a ramrod. He'll make sure you get it done. And the three of them complemented each other incredibly. And those stories are all true. And then I saw it, and like I say, I use that as my introduction. Welcome to Intel. Here's where you are.
Isn't that interesting? And then kind of telling people to behave accordingly, make use of that information.
That's exactly right.
This is who these.
Yeah.
What about I know over time the very idea of an Intel culture gets kind of codified and taught and is very explicit, and names are given to practices like constructive confrontation and could you see the basic elements of the Intel culture in the earliest years, or how did that evolve?
It obviously evolved, but I think that Andy very early was very disciplined about everything. It was say what you're going to do and do it. Meet schedules, no wasted BSing and so forth. But the early years were tumultuous, and Andy actually was very big on management training in the sense that we would bring in one consultant after the other and usually spit them out. But basically, bring them in, and we'd bring in guys that taught management by objectives. Bring in Drucker. We had Drucker, and so we would have a series of these almost every year, about every year, maybe every 6 months. Andy would take the whole management team, bring a consultant in, we'd have a 2-day session or whatever, and then we'd pick out what we wanted. And it was interesting, we never had the same guy twice, because as soon as you have this twice, they say the same thing. You already got it the first time. why are we doing this again? So that's why I say spit them out. One, learn what they've got, off you go, next guy. And then that kind of evolved into the whole culture in terms of how to manage. And then some things got carried to extreme, and we had one huge management by objectives thing where everybody had objectives and sub-objectives and other objectives, and pretty soon all the managers had to have a person in charge of the book, and adding objectives to it, and more objectives, and finally, screw it, let's go back to getting it done. But so it evolved, and but I think underlying it all was always just this basic discipline of being able to rely on your coworkers. If it's done, it's done, or you agree you're going to get something done, it's done. No political games, no, the check's in the mail, or you just didn't see any of the lying. You use the word lying as a bit of a negative, of people saying they'd done something, they hadn't done it. And so, in general, competence and results were respected, and that was the main culture, quite frankly. And then a lot of the other stuff got put on top of it, and then you started getting, Grove started getting older, and HR started taking over things. The next thing you know, we had to have a great place to work. And of course, I was still in the old school. One time I got so mad at somebody, I said, if this was such a great place to work, I'd charge you admission. I'll get back to work.
What about the angle that so many of the top management and early employees like yourself had pursued advanced degrees, involved with doing empirical research, experiment, real measurement, using instruments, true measurement, if you will. Do you think how do you see that, the importance of that background from so many of the people there?
Well, I mean, I think you answered the question, which is it clearly shaped the culture, and it was a sort of person that gravitated toward Intel and the sort of person that stayed at Intel. And the guys, we had the hardest time with the marketing advertising kind of thing, because those tend to be fluffier things. Right. And Grove, of course, would want to put metrics on them immediately, and so some of those people really struggled. Oh. And in terms of how do you deal in a company. But at the same time, we had some really great marketing. Ed Gelbach, for example, really brought a lot to the company. David Howe, those guys all brought something to it, and Grove respected them. And so he gave them, I guess, enough rope to do the job, but he also recognized that, you just didn't build the widget, you had to sell it. and you had to have the marketing and the things, branding and the things that went with it. So Andy evolved, Andy learned, but he was always very much on the discipline side. And like I say, Gordon was always behind the scenes, kind of approving or just setting the direction and so forth. And he was always kind of the guiding hand in terms of which direction we ought to be going. And so it worked out exceptionally well.
Well, as maybe we could talk about your move then into process development. Not just fixing the process as it is, but making the process as it needs to become. Yeah. And what that was like in this period of, let's say, the mid-'70s, and figuring out, how to figure out what directions to go to, just how you did the process development.
Well, I guess, to be honest, I hadn't really intended to follow a career in quality and reliability, and so at mid-'70s I started getting, I'm kind of tired of going to customers and kissing their ass because something failed, and so maybe I should go upstream and try to prevent it from failing in the first place and go develop it right.
Yeah.
So I talked to Gordon. Gordon, what are the chances of me, transitioning over to development? And then it turned out, there was an opening for running technology development, and Gordon asked, "Do I want to do it?" I said, let's give it a try. And actually went over to work for Ron Whittier, who had all of engineering at the time, and I was responsible for working on the process development. It was a small group, 30 or 40 people, and our goal was to really just develop the technologies. And it kind of grew from that into bigger and running all of the development and so forth. But,
right.
But yeah, I guess I kind of felt that, okay, I got a great education in solid state physics and so forth and so on. It'd be fun to just go upstream a little bit and work on that. And I was kind of happy with that, and I actually was thinking, I'm not sure I ever want to try and run manufacturing or something like that. But, okay, it's just problem solving of a different kind.
This would have been the era of so-called HMOS, correct?
Yeah.
And this is ion implanted N-channel?
Well, transistor. Basically, Dick Pashley actually was the guy that kind of did the design on those static RAMs, and he was a Caltech Carver student.
Oh, I didn't realize that.
And so he was in charge of the design group, combination design and process group, and so Dick worked for me at the time, and I remember he used to call it HMOS. I said, come on. There's CMOS and there's NMOS and there's PMOS. What the hell is HMOS? Well, it's high speed. Come on, And now we're going to have all kinds of MMOS and ZMOS and so forth. People are going to lose control of the naming here pretty quickly. Mm-hmm. But we got away with it. It's okay, HMOS. But no, at that time, ion implantation was just first coming into vogue, and you could adjust the threshold of transistors.
Right.
And that was the big deal, is that, we could adjust the transistors. In fact, he had a zero threshold transistor that could be used to shut the power on and off. But still, the whole idea was that you could control the thresholds much better. Performance got a lot better, and it got naturally better because we were shrinking dimensions. So, but that started the whole train toward shrinking. We had never really thought of shrinking a die, but in retrospect, it's obvious. But it was, it was one of those things where, okay, we design a technology, we build a bunch of stuff on it, then we go design another technology, build a bunch of stuff on it, and then I think it was actually Les Fidesz that kind of came up with the idea. So why don't you just take this one and shrink it? Oh, okay. Why don't we do that? So we started down that path. And I mean, shrink is a little bit of a misnomer. The first one truly was just shrink it. But after that, it was really...
Scale all the dimensions to the same percentage reduction.
Yeah, just
print it
the
smaller.
knob on the camera and change it. But that doesn't work long term. I mean, it worked for a little bit. But then now it was more compaction. Take the same circuitry, just tighten it up where you can. And that was kind of still the methodology. I mean, methodology, that's how you go from one generation to the next and get more die.
Right. And so that is, the basic transistor structures are getting smaller. So then you have a cascade of, compactions and, tightenings and changes in all the other geometry. Right. But is it true that that's all built off of this fundamental shrink, which is of the kind of transistor size?
Well, what you have probably hundreds of design rules. The design rule in terms of how big you can make a contact, how wide the metal can be,
right,
how thick the oxide, and so when you go from one generation to the next, you say, okay, we know we've got to get more stuff in here. So now let's take a look at where can we get a little tighter geometry. We have a new litho tool. We can print smaller lines. Okay, but we can't get these things too close together because we get capacitive coupling. So we can't scale that. So it's just a whole list of stuff that has to be integrated. And that's actually was one of the strengths of Intel's. We had a couple of guys that are really great at figuring out this integration. How do you get this stuff together? And then you have the specialists in each area, a guy that knows oxide etching, or a guy that knows metal, and
right,
so forth and so on. And not to besmirch IBM never had good integration guys. We would go to IBM and they would have 10 guys that were the best metal experts ever. And then you had 20 guys that were oxide experts. They didn't talk to each other. And there was nobody to pull it together. Whereas, we'd have one metal expert and one oxide expert, but we had a guy that could merge the two and come up with an integrated process that made sense. And I always thought that was a real strength that we had, that we could do that. And it kind of grew out of everybody trusting each other and working together as kind of the whole model that Intel was built on. It was never built on silos where, we don't talk to those guys.
Would those people, those specialists, have to integrate their expertise, so to speak, in the CAD tool, like these electronic design tools to actually do the layout of the chips?
Well, you come up with the design rules, right? The design rules, you would feed those into the CAD tool.
Okay, it's what.
And then the engineers, designers would know how close they can put the metal, how
right.
they would know the capacitive characteristics of the oxide and so forth. So you had all that, but and of course the guys would work together, because if the designers say, hey, we really can't live with this high capacitance between the metal layers, then the integration guy would have to say, okay, I need a little thicker oxide, but then I've got to make sure I can get a contact through it and get all this stuff figured out so that at the end of the day it all worked. But the integration of all that stuff, the collaboration was phenomenally important.
And that has to happen before you. That's how you define the design rules.
That's how you get a working part at the end of the day. It's usually the objective.
I guess that's the ultimate test.